we've talked about this before, which is usual versus unusual. Well, if we're talking about probabilities, something's going to be considered unusual if it's less than or equal to 0.05, which means it's going to be less than or equal to, as a percentage, 5%. So if a probability is less than or equal to 5%, it is going to be considered unusual, is what we'll use that term for. So let's look at this first example here. When the drug Viagra was tested, 117 patients reported headaches and 617 did not. Use this sample to estimate the probability that a Viagra user will experience a headache. Well, they said how many experienced headaches. So we're looking for probability that they get a headache. Well, how many of them got a headache was the 117. The question is out of how many people? They did not tell us out of how many people we were going to have, so we need to figure that out. So we had 117 who had a headache and 617 who did not, which means how many total patients did they actually talk to? Well, I need to take the 117 and add it to the 617 to figure out what the total is first. Well, let's see, 117 plus 617 is 734. So that will be our total number of patients here. So we'll do our 117, the headache, out of the total, the 734 we just found. And that will give us a value or a probability of 0.16. And the question is that considered unusual? And that would be considered no, not unusual. Remember, unusual would be anything less than 0.05. This is 0.16 or 16%. That is definitely not considered unusual. The last thing that we're going to talk about is what's called a complement, or the opposite. So if you've got an event E, which talks about the numbers 10 or greater, its complement, and a lot of times you'll see this little kind of like a little bar next to her, or you'll see a hat. Either way, those mean the complement or the opposite. Would mean anything that's not 10 or greater is the opposite or complement. And that would be, well, if you're not 10 or greater, that's the 1, 2, 3, 4, 5, 6, 7, 8, 9. And the ideal with complements is you could find probabilities for them. So the probability of you landing in the group E is, well, there's 3 out of 12 numbers in that first group, which is 0.25. Well, notice the complement, anything that's not 10 or greater, is the 1 through 9, which is, those are 9 out of the 12 numbers, which is 0.75. Now, what do you notice about the event and its complement? It's subtle, is they add up to 1 or 100% of all the data. And that's what's always going to happen. When you have two events that are opposites or complements, their probability should add up to 1 or 100% of all the data. And that's all this little rule is saying down below, is that if you have two events that are complements or opposites, they're going to add up to a 1 or 100%, which also means that the second piece is true. If you have one and you're trying to find the other, the complement, you can just subtract it from 1 or 100%. Good example. If the chances of it raining are 20% or 0.20, the chances of it not raining, the complement would be the rest, 80% or 0.80. Because they have to add up to 1 or 100%. Here's another one. On a multiple choice test with 5 possible answers for each question, what is the chances of getting the question correct? So we're going to start writing this a little bit different. I'm going to draw a P here for probability. What are we looking for? I'm going to put inside of this what we're looking for, correct. So what I'm meaning by this is the probability of getting the question correct. Well, remember they said that there are 5 possible answers, which means my total is 5, my denominator is 5. What are my chances of getting it correct? Well, remember, there's only one answer that's correct on a multiple choice test. So it's 1 out of 5, which gives me, if I divide that, 0.20 or 0.2. So if I wanted to ask part B, which is what are my chances of getting it incorrect or wrong, that's your complement. That's your opposite. Well, if you didn't get it right, you got it wrong. So if 0.20 or 20% were right, or your chances of getting it right, what are your chances of getting it wrong? The rest of it, the other 80% or 0.80. So you can just subtract that from 1 to get the rest, the 0.80%. Or, sorry, 80% or 0.80 as a decimal. Again, just another reminder, we're going to consider something unlikely, or we also use the term unusual if a probability is less than 0.05. That is still our threshold, 0.05, which means less than 5%. So when we use the terms unusual or unlikely, kind of use them interchangeably. They mean the same thing. It's still the 0.05 threshold. So this next one, what is the probability that a randomly selected person never uses a credit card? That's what we're looking for in this first one. Randomly selected person never uses a credit card. Well, they go ahead and tell me that 169 never use their credit card. So that will definitely be my top number. The question is, what's my bottom, my total number? They left this out as kind of just gave us a bunch of pieces of information about people, which is 169 said that they don't use a credit card. 1227 say that they use it sometimes, and 2834 say they use it frequently. They never actually give us the total, which means I need to find it, which means I need to go ahead and add up all the groups they did give me, which is the 169, the 1227, and the 2834, to add those up to get my total. So let's see what we get when we add up the 169, the 1227, and the 2834. We get a total of 4,230. So that will be my denominator for my fraction. And to actually find the probability, I actually need to do the division here. The 169 divided by the 4,230, which will give me 0.04. Roughly, depending on how you round. And the question is this unlikely or unusual? Well, is it unlikely or unusual? And the answer is yes. Why is that yes? It's yes because it's less than 0.05. So yes, because it's less than 0.05, the chances of that happening, the probability. That's what we're referring to being less than 0.05. And we're going to come back to this idea of unusual, unlikely over and over again. So that threshold of 0.05 or 5% needs to not be forgotten.